class. I am Mrs. Rushali Chaudhary, lecturer Praveen Patil Polytechnic. Today we are going to learn Applied Science Chemistry, subject code 22202. In that we are going to learn the fuel. What is a fuel? Any substance which on combustion, which on burning produces a heat energy. It's called as fuels. Fuels are the different types. First, it is called as a primary fuel and a secondary fuel. Again, it is divided into the three categories: solid fuels, liquid fuels, and a gaseous fuel. Earlier, we learned what are the solid fuels. In that solid fuels, when we are talking about the engineering purpose, we deal with the coke. There are four types of coke available in the market, that are peat, lignite, bituminous, and anthracite. We learn how it is produced, the properties, and application. Today we are going to learn liquid fuels. Liquid fuels is important for the commercial as well as the domestic purpose. Where we are using the liquid fuels, we can use for the vehicles, we can use at a household purpose, because liquid fuels are easy to carry everywhere. At the same time, calorific value, that is the amount of energy produced, it's also high. So it is a economical, convenient, easily manageable, and less polluting fuels. And mostly these liquid fuels are obtained from the petroleum or crude oil, or we can also call as a khanij tel. What are that components? Petrol, kerosene, diesel, methanol, ethanol, butanol. These are the liquid fuels we are using for the industry, for the different machineries. How it will obtain from the petroleum? What is a petroleum? It is a crude oil which is obtained below the oil water surface, below the sea level, as well as the earth surface. So from the crude oil we have to first remove the solid impurities. The crude oil is a mixture of solid, liquid, and a gaseous substance. These are allowed to stand undisturbed as it is for some time. Then the heavy solid particles settle down and gases are evaporated. And the thick liquid we will get, that is a centrifuge, where the solid get removed. Then after whatever the water content present, that is removed. That process is called as a removal of water. That is process is called as a Cottrell process. The crude oil obtained from the earth's crust is in the form of stable emulsion of oil and brine. Brine means salt water. This mixture is then passed through two different highly charged electrodes, will destroy the emulsion film, and the colloidal water droplets separate into the bigger droplets and get separate out from the oil. We are separating water from the oil. After that, we are removing the harmful impurities from the crude oil, because if sulfur containing impurities are present in the crude oil, and which is again carried forward to the petrol and diesel, it is going to cause a lot of pollution. The sulfur compounds get converted into the insoluble copper sulfide, which is removed by the filtration. Substances like a sodium chloride and MgCl2 is present, and which corrodes the refining equipment, and formation of corrosion scale will take place, which is removed by technique called as electrical desalting and dehydration. Main important process is fractional distillation. Whatever the crude oil obtained from the refineries, we are going to heat about 4000 degrees Celsius in an iron retort, which are going to produce lot of vapors, hot vapors, and which are passed through the fractional column. It is a tall cylindrical tower containing a number of horizontal stainless steel at a short distance, and it is provided with a small chimneys covered with a loose cap. As the vapors goes up, it will get cooled gradually and fractional condensation take place. Higher the boiling point fractions condenses first, later the lower boiling point fractions. See, this is the distillation assembly. At the bottom we are putting the crude oil. When we are putting a crude oil, what will happen? And we are heating about 4000 degrees Celsius. As we are heating at very high temperature, molecules present in that get vaporized, which is having lower boiling point like a LPG, liquefied petroleum gas, which is having a 20-degree boiling point, which get evaporate first, which will directly goes to the top level, and from this we are doing a fractional condensation. We are separate out LPG that is having a carbon number C12C4 at a 20 degree. Then after, as the temperature increases, 70-degree boiling point like a naphtha, carbon number is C2C9, that gets separated. These vapors are get separated, that are the petroleum product. Then after, we are increasing the temperature at 120 degree, gasoline get separated. For the 170 degree, kerosene gets separated. 270 degree, diesel gets separated. After that, higher temperature 400, 500, lubricating oil, waxes, polish, that gets separated. After that, we will get a heavy fuel oil that is used for the bunker as well as the boiler. Whatever the residues remain here, which is not get evaporated, which is not get boiled due to high temperature, that is the bitumen, that is called as a damper bitumen or asphalt, which is used for the making roads and the roofing. So first we are going to heat it. First we are going to heat crude oil in the iron retort. This is the iron tower, so, and which is having a fractional condensation. So as per the temperature, different fractions get separated out, and different fractions is having a different properties as well as the application. First we are going to separate out lower boiling point like a gaseous molecules, liquefied petroleum gas, then gasoline, naphtha, paraffin, diesel, fuel oil, lubricating oil, and last residue is called as a bitumen, which is used as a asphalt for the road making. The fractions like a refinery gases, petrol, naphtha, kerosene, diesel, lubricating oil, fuel oil, residual, which is having a higher boiling point. Refinery gases, boiling point is very less, so even at a room temperature they are present in a gaseous, while the residue, that is the bitumen or the asphalt, which is having a higher boiling point, so even at a 400 degrees Celsius it is not get melted, it is not get evaporated. In viscosity is increases. For the gas, viscosity is very low. Petrol slightly increases. When we are moving towards the lubricating oil, fuel oil, viscosity is higher. They are the thick. Residue, that is a solid material, very high viscosity. Flammability decreases. Refinery gases, LPG, petrol are easily flammable. They are easily catching fire, so they are having a lower boiling point. While we are going towards the downward, we will observe that the flammability is decreases, chain length increases. Refinery gases like a LPG, chain length is carbon 1 to carbon 4. Alkane group is carbon 1 to 4. But when we are moving towards the residue, very high carbon numbers. Like a refinery gases, number of carbon atoms is 3 or 4. Boiling point below 30 degree, where we are using this refinery gases, that is called as a LPG, liquefied petroleum gases. We are using for the cooking purpose, household purpose as well as the industrial purpose. Another one is the gasoline. Carbon carbon number is 729. Boiling point 100 to 150 degrees Celsius. It is used for the fuel of a car engine. Similarly, naphtha, carbon number is 6 to 11. Boiling range is 70 to 200. It is used as a solvent. It is also used in a gasoline. Kerosene, carbon number 11 to 18, boiling range 200 to 300. It is used as a fuel for the aircraft as well as the stores. Diesel oil, carbon number is 11 to 18, boiling point 200 to 300. It is used for the vehicles as well as the train as a fuel. Lubricating oil, carbon number is 11 to 18, boiling point 300 to 400, very high boiling point. It is used as a lubricant for engines and machines. What is the lubricant that we are going to learn in a second semester? Actually, lubricants are the substance which reduce the friction. Fuel oil, having a carbon number 20 to 27, boiling point 350 to 450. It is it is a fuel used for the ships and heating purpose. Gas, greases and wax. These are the semi-solid residue obtained. Carbon number is 25 to 30, boiling point 400 to 500. It is used as a lubricant as well as for making of candles. Whatever the residue remain, which is having a about 35 carbon number, that is called as bitumen, very high boiling point. It is not get melted at low temperature. It is used for making a road surface as well as the for roofing purpose. Here we can observe that when we are heating the crude oil at a high temperature, temperature is going to decrease. First we will get a gas which is having a carbon number C1 to C4, having very low boiling point. At 25 degree, gas gets separated. Temperature is higher at the bottom. Viscosity is higher at the bottom while the boiling point increases. Thank you class for your attention. If you have any doubt, you can mail me. Thank you so much.